Okay, so I'm going to do a few of these videos over Unit 5 assignment packet where I just pick a few in each section to give you some guidance, and the goal would be not to teach you for the first time, but you've already learned it in class and now you're practicing it, and maybe you're trying a few each night and you've forgotten something. So this can be used to rewatch if you get stuck on a similar problem, but I've chosen these four as some that are, you know, a good guide and maybe a little tricky just to help you out, and let's see how it goes. So I'm going to start with this number 3. Anytime you're dealing with a negative under a square root, you actually want to handle that negative first, and you probably remember from class that the negative comes out as an I. So I'm going to break this into I square root 9 plus I square root 100. Now I do that first, and then I decide, okay, can the number be broken down as well? And of course these can, because what is the square root of 9? Well, that's just 3, right? So I've got an I in the front, and now it's times 3. So I'm actually going to write that as 3I plus, what's the square root of 100? 10, and since there's the I with it, I'm going to do plus 10I. So the I and the 3 can be written in either order. The same thing with the 10 and the I. It just looks better if the number's in front of the I, okay? Now, these are like terms, and anytime you're adding or subtracting, if they both have an I, then they're both the imaginary components, and you are allowed to put them together. Okay, so that's my final answer right there. All right, so there's your number 3. Okay, number 10, same thing as I said up here. You always want to handle the negative underneath first. So I'm actually going to turn this into I root 5 times I root 8. And then what you do on a problem with radicals, anytime you're multiplying radicals, guys, you want to do whatever's outside times whatever's outside. Then under the radical, whatever's under it times whatever's under it. It is legal to multiply the 5 times the 8 now, and you will get, what is that, 40? Okay, so we have an I squared and a square root of 40. So the way that I would approach it is, first of all, I squared is something you should be triggered by because it's actually equivalent to something else. You should have an I chart. And this needs to be memorized, by the way, this I chart. I is I, just FYI. If you ever see an I, leave it as an I. If you see an I squared, turn it into a negative 1. An I to the third, negative I, and an I to the fourth is a 1. So when I see this I squared right here, I'm actually going to replace it with a negative 1. Then I'm going to try to break down the square root of 40, okay? Now, how do we break down the square root of 40? Well, you look for something that goes into 40 that has a square root. So for me, I know that 40 is 4 times 10, right? So then if I break down the 4 times 10, well, the square root of 4 is just a 2. So that 2 I'm going to combine with the negative 1 that's in the front. So now it becomes a negative 2 because I'm just multiplying those, right? This is multiplication when they're stuck together. And then the square root of 10, well, there is no square root of 10, and so that stays under the radical. So that would be my final answer for something like number 10. Okay, moving on to 15. On 15, whenever you have two complex numbers multiplied together, you just need to FOIL it. You really can, multiplying is fine. You can always multiply any two things together. It's whenever you try to add or subtract that you have to be careful. So since these are all multiply here, I'm just going to FOIL. So first times first. Outside is 15I. The inside is 8I. And then the 2 at the back, let's see, 4 times 5 is 20. I times I is I squared. Okay, so when you FOIL this out, you should be getting this, and now you get to combine like terms, okay? And before I combine like terms, let's do that same thing we did over here on the other side. If there's an I squared, you can totally replace the I squared with a negative 1. So what is 20 times negative 1? Well, 20 times negative 1 is just a negative 20. So all I did was erase the erase the I squared, and then I changed the sign on my number. Okay, now let's combine like terms. There's a 6 and there's a negative 20. So that makes a negative 14. And then in the middle here, I've got a plus 15i and a plus 8i. So since they both have an I on them, they are like terms. And you can put those together. And that would be how you write your answer. It's a better form to put the real number in the front and the imaginary number in the back. So you may have seen a plus bi in class. Whenever you get an answer, you do want to write your answer in this form. Real number plus imaginary number. So this is my answer. Okay, the last one is number 20, and it's going to be fun because there are radicals everywhere. So before I start multiplying this out, remember what I said. If there's a negative under the radical, always deal with that first. So I'm going to recopy this problem as I root 2, and then same thing, I root 2. Okay, so I just pulled out the negative underneath, brought it out front as an I. Now you get to FOIL. Okay, so first times first. When you're multiplying radicals, remember, whatever's out front times whatever's out front, and then whatever's underneath times whatever's underneath, okay? Now the outside, there's an I times an invisible 1, and actually it's a negative I, so I'm going to put minus I, and then underneath is a 3 times 2, which is a 6. The inside is a 4 and an I, so plus 4i, and then square root of 6. And then my last terms are this one and this one. So when I multiply those together, I'm going to get a negative I squared times the square root of 4. And now we simplify this. Okay, should be pretty easy, this part. The square root of 9 is 3, right? What is 3 times 4? 12. So I'm just going to turn that into a 12 real quick. Same thing down here. The square root of 4 is just 2, right? So we can change that. And then what is an I squared? Well, I squared is negative 1, and I have the negative of a negative 1, which makes it a positive. So this just turned into a good old-fashioned plus 2 right here. And now we combine like terms. The real number in the front plus the real number at the back is 14. Okay. Now these are like terms. Now what makes them a like term? Well, the fact that they both have a square root of 6, that's a good sign. And then the fact that there's an I in the front of both of them. So what is the rule with adding radicals? Well, when you add radicals, whatever the radical is, you just leave the same. So it's the square root of 6. And all you're really adding are the coefficients. Okay, so here's a negative 1i and a positive 4i, so that would make a positive 3i. So that would be your final answer on something like that. So as long as you remember to handle those negatives first and make them an I, then you do your normal FOIL and your normal radical math, as long as you can remember that radical math. But hopefully I've given you a little bit of preview of that. Now in this section, you're just going to use your notes. All you're doing is identifying what kinds of numbers these are. So, you know, for instance, pi is the most famous irrational number out there. So you better call it irrational for sure. But you should have all these sets and subsets of different types of numbers in your notes. And so you're just going to say, okay, it's irrational, but it could also be blah, you know. So I don't know what all sets you have, but you'll need to look that over. I know for sure you could call that a complex number, because even though you don't see it, you could look at pi and say, oh, there's just an invisible 0i behind it. So you could always call these things complex. And is it a real number? Yes, it's a real number. So anyways, there's all kinds of stuff. Just look in your notes for this. And then on another video, on a later video, I will do the next section. So work on these 2 or 3 a night until you get them all done and all answered. And then we'll be on to the next section.